All right, this is where we ended off last time, so we'll just keep on going. Actually, let me go ahead and launch my little thingy thing here. Yep. Okay. So these are some general questions. What affects your weather the most? And it's those two things. Your latitude, which is how far north or south you are from the equator. And again, we're just shy of 45 degrees north latitude. If you're going up to like Traverse City area, you'll actually cross that point. It's right around that same area. And then the altitude is your elevation, how high up you are in like the mountains or so. Okay, the Coriolis effect. That is the wind patterns is the result of the movement of the Earth, the rotation of the Earth. So we'll see how this looks right here. So there's a little example we'll do of this in class, but you can kind of see, I mean, the Earth is moving its fastest at the equator because it's moving the same speed up and down, but because the equator is the largest distance compared to the poles are very, very small in distance if you have to go in a circle, the equator has to move much more quickly. As a result of that, the wind is being, if you will, being pulled to the left, as this picture is kind of showing there. So as the air moves from the north or the south towards the equator, it is getting pulled because of its lack of speed in relation to how fast the equator was going. And it works just the opposite from the westerly winds, which you can see on there. They actually will pull to the other direction. This works a little bit better in a demonstration, which we'll do in class. But you do see that trend, and we actually see this as our wind patterns. If you can kind of see right in this area where Michigan is, that's kind of how our weather goes. So a lot of our weather will come from the Gulf of Mexico, hurricanes and such, and wind its way up here. Sometimes it misses us. It doesn't have to go to Michigan. But a lot of these things will turn into what they call those nor'easters. The weather kind of finds its way moving in that general direction. Okay, and oceans have their own circulation as well, based again on the wind patterns, but then also on the Coriolis effect. They are called gyres. And this gives us a general idea of how they kind of move around. I don't know if I have another one on here or not. I don't think, oh, I do. Okay. So you can kind of see the pattern in which they go, again, based on the Coriolis effect, that in the northern hemisphere, these gyres typically will flow in a clockwise fashion. And then in the southern hemisphere, they will typically flow in a counterclockwise fashion. One of the things that's kind of interesting that they're talking about right now with some science is the potential shutdown of some of these ocean currents. For example, Great Britain is unusually warm. It always has been, or in modern history. And it is because of these warm waters that come from the equator and rush on past Great Britain and keep it warmer than it relatively would. And then what happens is these waters eventually will cool, they're relatively salty, and they will sink. And it's a conveyor belt, and this process keeps on going. Well, because of the melting of the polar ice caps, or in this case Greenland, it's diluting that water down. So you're not getting as much of salty water in this area. It's less salty. It's less salty, it's less dense, it doesn't sink. So climate scientists are concerned that this is going to eventually slow down or shut down, and that's going to have a big impact on Great Britain's climate. And this is just another example of what I'm describing here. I'm not going to go over it again, but this is that conveyor belt where you have warm water, then it flips down and it cycles through. It just keeps moving. It doesn't just sit in one place. But if you want to pause it and take a look and read this on your own, I would advise you to do that. All right, another big weather pattern, which has increased in some frequency in the last so many odd years, is El Nino. And there's lots of different ways that it affects weather. And I'll show you a slide of that in a little bit. But the one that College Board and us will focus on is pretty much South America. So that's what we got going on over here on the right-hand side. This is out into the Pacific. And of course, you got North America hanging out here. Normally, the wind will blow from South America west. And you can kind of see that going on. What that does for South America is it creates, again, a cycle, because if it's pulling that water westward, you're going to have this water moving up along the coast, and it's nutrient-rich, upwelling. It's nutrient-rich water that feeds all the wildlife, and it's this, again, it's a source of life on the coast of South America. It's good for them, everybody. And that's normal. But then you get things like El Ninos, which is this little example here, where the winds slow down, or in some cases, they actually will go in the opposite direction. And then that shuts down this upwelling of water, cold, nutrient-rich water off the coast of South America. And then it changes patterns over there. So they don't have this nutrient-rich water, and the life, as you will, in that general area, it doesn't do as well for that year or so, or months that is happening. And this is just a climate map of showing the whole world of areas that it is being affected. And you can see what happens during like an El Nino-ish kind of year. So this is generally how affected. So it's not something that we can always just pinpoint and say, oh, it's an El Nino. This is what's happening. Well, it depends where you're at. But we tend to focus on this South America when we're talking about El Nino. Okay, another phenomenon, which is pretty interesting, is think of like Washington State or anywhere where you have coastal mountains. Typically, many times you have cold, wet water or air moving from the ocean towards the land. And as it gets pushed up a mountain, it cools more so and drops its precipitation. And then when it comes down, it's warmer and it absorbs that moisture and it's dry. Typically there's a desert. And Washington is a great example of that with the Cascade Mountains, where the Seattle area is relatively wet, but then in Eastern Washington, it's relatively dry. And this is another example of Olympic National Park. This is over in the northwest corner of Washington State. You have that wet air mass moving constantly or towards the peninsula. And as it goes up this mountain, again, you get a lot of precipitation. So as a number, they can get like 20 feet of precipitation on the peninsula. Yet these towns that are over here in this rain shadow might get 20 inches. So 20 feet to 20 inches because all that moisture has been deposited up here in the peninsula. All right, biomes. This is a big part of our discussion. Biomes, as you can see, are characterized by the things that are there. Typically, we think about the plants and the animals. So we visually see this is what lives here. We count these as being similar to other locations. So again, you can see the climate, the soil, plants, and animals. This is the things that we can visually see. This is something, it's like a vocab word where biomes will intersect. It's not like hard lines that I'm in a prairie, now I'm in a forest. Usually there's like a bleeding between the two. Those are called ecotones. And ecotones are where you have, again, more biodiversity because you have some stuff that lives in both areas. And then you have some other things that kind of like to be in this in-between area. So you kind of get three things going on in these ecotone areas. And again, many of these things are what you would call generalists because they can live just about anywhere, relatively speaking. All right, these are some very common biomes. And you can kind of see, like, for example, like where we live here in this kind of, I don't know, I guess we call it a greenish color. That is a temperate seasonal forest, also known as a deciduous forest. That's where we live. One of the largest biomes in the world, I'm not going to cover all of these, is this kind of darkish greenish area here, which is called a Boreal Forest. And sometimes it's also known as a taiga or a coniferous forest. But you can pause it and take a look at these as much as you like. We're going to hit them all eventually. This is another way of looking at them. So you can arrange these based on their temperature, where you're going to find them. So for example, 30 degrees is kind of warm. Deserts, tropical deserts. Excuse me. These are all kind of like tropical locations. But then also with the precipitation. So as those two things play together, you'll get these biomes. So this is what determines where you're at on the planet, is mostly based upon your precipitation and your temperature. Okay, good time for a break.